Welcome back. So if you've watched the demonstration and done a bit of playing and thinking about this, you hopefully have now absorbed once and for all the moral of handling division involving floating point numbers in Java, which is to say, if you want to do a division sum and you would like a floating point result, what you have to do is to make sure that at least one of the operands is a double. Because if you make the classic mistake of allowing both of the operands to be integers when you expect a floating point result, it will not work. So don't fall down that hole. Now we're going to go on and talk about command line arguments, and in particular about how you can get data from the outside world into your Java program. You've met command line arguments in operating system contexts before. If nothing else, you've met them in this lecture when we talked about invoking the command javac and giving it the argument, which was the name of a file we would like the Java compiler to compile. And again, when we invoked the command java and gave it the name of a Java class, which we would like the JVM to interpret. Here's another example. This one happens to be a Unix command. Mukdir my Java code instructs the operating system to please create a new directory and name it my Java code. And here the terminology is that mukdir is a command and my Java code is an argument. Of course, we don't want to be limited to just the commands that are built into our operating systems. We would like to be able to write our own Java programs in due course and give them arguments on the command line as well. And we can do that exactly similarly. So here we have the command Java, which, recall, starts the Java virtual machine, it starts the Java interpreter. We give it the argument add, which names the Java class that we would like the interpreter to interpret. That now gives us a program which itself can take command line arguments. So 3 and 6 are the command line arguments for the program add. Let's have a look at the program add. Here it is. Just like before, it's described as a public class whose name is add. We saw that already when we named it on the command line. Just as before, it has a public static void main method with a string array args as its argument. This time we're going to use those arguments because when we actually run the program, that args array, we'll talk about arrays later on, but for now you can just think of it as like a fixed length list. That array args is going to be filled up with whatever arguments the person who invokes this program gives on the command line. So in our example earlier on, we would expect args to contain the integers 3 and 6, represented as strings, because operating systems deal with strings. Okay, so what do we have to do with this string array? The first line, is an example of what we saw before. It's a statement which both declares a variable, in this case a, which is going to hold an int, and initializes it. It initializes it to the result of evaluating the rest of the line, in this case integer.parseInt args0. You already met integer.parseInt before. It was the mechanism that we used to translate from a string to an integer. Previously we saw it applied to a literal string. Now we're seeing it applied to something else, which is a string, namely args0. Args0 with the square brackets is the way we denote the first element of the string array args, which represents the command line arguments to our program. First, you might say, 0. What's going on there? What's going on there is, as we'll see later, that Java arrays start counting from 0. So the first element of an array is, somewhat confusingly, called the 0th index. It is what you find at index 0 in the array. This is very common in programming languages. So in our example where we have 6.3 or 3.6? I've already forgotten. Anyway, it's whatever the first command line argument was. The second line is completely similar. It declares an integer variable b and assigns to it the element of the string array args, which is found at index 1, namely the second element of that array. Now we have in our program two integer variables, a and b, and we can add them up and print out the result. And that's what the program does. In passing, by the way, this is an example of how we have to be sure to obey the capitalization conventions within Java, because it's the fact that integer starts with a capital I that lets me know that parseInt is a static method within class integer, as opposed to integer being an object to which we're sending a message parseInt. So the capitalization conventions gives us extra information that helps us to read the program correctly. That's just a by the by. What happens if we miss an argument? Well, we don't get some clever kind of partially instantiated program. What we get is an error. If we don't provide anything as a value for args1, and then our program tries to use something that it expects to get from args1, as it does in our int b line in our program, the Java interpreter will complain. In this case, the way it complains is it raises an exception called array index out of bounds exception. And what that means is you used an array and you gave it an index, in this case 1, which was out of bounds, which was out of the range within which the indexes into this array were actually defined, which is just a fancy way of saying you didn't provide a second argument to this program. So in summary for today, what we've seen: Java is an object-oriented imperative programming language. That means that statements are executed step by step. Programs comprise statements which are executed step by step. Objects carry state and have behavior, and they have an identity. I haven't put that in the summary here. It's a compiled language, which means that you have an edit, compile, run sequence, although sometimes if you use an integrated development environment, that might be somewhat obscured by the fact that the IDE might silently do the compilation for you. The entry point into every Java program is the main function, within whichever class you start the program at. Variables carry values of different types, and some of those types are built-in types, built-in basic types, which always begin with a lowercase letter, like int, char, float, and boolean, and others are elements of classes, like string. And we talked about the fact that for many purposes at the moment you can think about classes and types as being synonymous, even though they're not quite synonymous, because one of the things that a class does is to define a type. You can use a range of arithmetic operations, very much as you would expect. You can convert between types, and we saw various different ways of doing that. We saw, for example, the parseInt method for converting between a string and an integer, but one of the main methods is to cast. That was what you saw, where we put a type name, like int, inside round brackets, and we put that in front of an expression whose type we wish to change. And we saw how programs can receive user input at startup time using command line arguments. Later on you'll also learn how to get user input during the time the program is actually running, which uses a different mechanism. That comes later on. The reading that you should do in order to make sure that you have got not just this summary but also all the details that you'll need comes either from the Java tutorial or from Objects First. My favourite of these is the Java tutorial. Some people prefer Objects First. What this means is that my page references into Java tutorial are likely to be more reliable than my page references into Objects First. Since they both have different editions, you may have to pay attention to the possibility that some of these page numbers may be wrong for your edition. Let me know if you come across any bad cases, but I hope they are mostly just about right. Those are the pages that you should read corresponding to this lecture. Notice that we will use IntelliJ as our IDE, our integrated development environment, whereas the book assumes NetBeans. Sometimes you might also use Eclipse. Some of the Chapter 2 material we will come to later. I've already said we'll talk about arrays later. I suggest skimming the stuff that comes contiguously in that section of the book, and then rereading them more carefully later. I tend to find that actually skipping sections of a book doesn't actually work too well, but experiment and see what works for you. And we'll stop there.